Hi everyone, welcome to today's class on chemical reactions and equations. In the previous class, we learned about combination reactions and decomposition reactions. Today we will be studying about two more reactions. The displacement reactions and double displacement reactions. Displacement and double displacement reactions. But before we start discussing about these two, displacement and double displacement reactions, we will be discussing a few more points about the combination and decomposition reactions. Hope you remember what limestone is. It is calcium carbonate. And what is quicklime? We learned about all these substances in the previous class. Quicklime is calcium oxide. And what about a slaked lime? Slaked lime is calcium hydroxide. Now, you know how to convert limestone to quicklime? It is by decomposition, and you have to heat it strongly. So this will give you calcium oxide and carbon dioxide. It is a decomposition reaction. Now, if you want to convert quicklime to slaked lime, what do? You add water. So calcium oxide undergoes combination reaction to produce calcium hydroxide. So the first reaction is decomposition and the second reaction is combination reaction. So right from CaCO3 you can get CaOH twice. Now this reaction we have discussed because we need to understand what whitewashing is all about, the principle of whitewashing, the chemistry of whitewashing. So which substance is used for whitewashing? It is calcium hydroxide, which is slaked lime. So you apply calcium hydroxide on the walls. So what happens is this calcium hydroxide reacts with carbon dioxide present in the atmosphere, and this is a combination reaction to produce calcium carbonate, which is a white substance. So this is the principle of whitewashing. So what you apply on the wall is calcium hydroxide, which is a colorless substance, and by reaction with the carbon dioxide it gets converted to the white colored calcium carbonate. Now let us discuss about decomposition reactions in a little more detail now. We had already discussed it in the previous class. Now we have studied a few examples of decomposition reactions. Which are the examples you have studied? If you learned about a decomposition of lead nitrate, you studied about a decomposition of silver chloride as well as decomposition of water. Now if lead nitrate is heated strongly, you get product PbO plus NO2 plus O2. Now if you balance this equation, try to balance the equation, it will be 2 PbNO3 twice, giving you 2 PbO plus 4 NO2. See if it is balanced. Now for this reaction to happen, you have to heat it strongly. So when a decomposition reaction happens in the presence of heat, we call it thermal decomposition. So this reaction is an example of thermal reaction, or it is a thermochemical reaction. Thermochemical means a chemical reaction which happens in the presence of heat. Now let us see the next equation we've learned. Silver chloride, you've seen it gets converted to silver and chlorine, and this reaction happens, this again is a decomposition reaction. This reaction happens in the presence of sunlight. So since it happens in the presence of sunlight, we call it photochemical reaction. Photo represents light. It's called photochemical reactions or photochemical decomposition. Let us see the next decomposition reaction we had studied in the last class. Water can be decomposed to produce hydrogen and oxygen. And this happens in the presence of electricity. Therefore, we call it electrochemical reaction. Electro represents electricity. So using electricity, we decompose it. So we call it electrochemical reactions. Now let us discuss about displacement and double displacement. Let us see some reactions first. So over to the reactions. You can see a beaker containing copper sulfate solution and a strip of zinc. You can see right now zinc is shining. Now we put it in a copper sulfate solution which is blue in color. Make the observations. You can see something getting deposited on the zinc, and the color of solution is slowly becoming pale. You can see a reddish brown substance is getting deposited. We will discuss this reaction in detail. So can you see the color of the solution is changing from blue to pale blue colored, and there is a brown precipitate also, brown deposition also. Over to the next reaction. Again, you can see a little copper sulfate in a beaker, and we put some iron nails in it. You can see right now iron nails are shining, and let us keep it for some time and see what change happens. So you can see the iron nails which are taken out from the solution, and also see the color of the solution. We will again discuss it in detail. Let us see the next reaction. What you can see in the test tube is sodium sulfate solution, and we are adding barium chloride. The moment the barium chloride comes into contact, you get a white precipitate which is barium sulfate. Let us discuss all this in detail now. So we have seen two examples of displacement reactions and one example of double displacement reaction. We will be seeing some more examples. The first reaction was zinc reacting with copper sulfate. Copper sulfate is blue in color. Because of this reaction, you get a zinc sulfate which is colorless, and copper is getting deposited. You can, if you want, you can see those videos again if you have any doubt. So what happened in this case is zinc has displaced copper from copper sulfate solution. Now copper sulfate is slowly getting converted to colorless zinc sulfate. That is why the solution became colorless after some time. So out of copper and zinc, which is more reactive? It is zinc, because zinc is able to displace copper from copper sulfate. So zinc is more reactive. What would have happened if we do the reverse way? We put copper in zinc sulfate. there will not be any reaction because zinc is more reactive. Copper cannot displace zinc from zinc sulfate. So copper is less reactive, so it cannot displace zinc from zinc sulfate. Because copper is less reactive. Same way we have seen another reaction where iron is treated with copper sulfate. So here again you observed the changes. We got ferrous sulfate, that is why the solution became green in color. Copper sulfate was blue in color. After the reaction, you must have observed this. So the solution became green because copper sulfate got converted into ferrous sulfate, FeSO4. So who is displacing, what is displacing what? Fe is displacing copper. So out of Fe and copper, which is more reactive? Obviously Fe is more reactive. That is why it is able to displace less reactive copper. So such reactions are called displacement reactions. Now let us see the double displacement reaction which we have seen. This reaction, okay, we will see one more displacement reaction. Lead reacting with cuprous chloride giving PbCl2 plus Cu. Here again there is, you can see there is a displacement reaction. Lead is more reactive, so it is able to displace copper from CuCl2. This again is a displacement reaction. So which is more reactive? Out of copper and lead, lead is more reactive. That's it. Now let us discuss the double displacement reactions which we have seen. One reaction we have observed just now, one reaction we had observed in the previous classes. So we will discuss both the reactions, double displacement reactions. We have seen barium chloride reacting with the sodium sulfate. Sodium sulfate is Na2SO4. So because of the reaction you get barium sulfate, which is white precipitate, and sodium chloride. That white precipitate you had seen in the test tube was barium sulfate. And sodium chloride remains in the solution. It will not be a precipitate because it gets dissolved in the solution. So here what happens is barium is displacing sodium from sodium sulfate. The reverse is also true. Sodium is displacing barium from barium chloride. So as the name indicates, there are two displacements, so we call it double displacement reaction. Sodium chloride will remain in the solution. Now let us see the other reaction which we had seen. Lead nitrate, we had seen this reaction already. Lead nitrate was made to react with the potassium iodide, and we got a yellow precipitate of lead iodide, which is PbI2, and potassium nitrate will remain in the solution. So this becomes yellow precipitate, PbI2. Potassium nitrate will remain in the solution. So here again you can see lead is displacing displacing potassium. Lead displaces potassium, and potassium displaces lead. So as the name indicates, there are two displacements, so we call it double displacements. So such reactions are called double displacement reactions. So we have seen four reactions: combination reactions, displacement reactions, decomposition reactions, and double decomposition reactions. You can find out more examples. That's all for today's class. See you in the next class.